fraction. Hey there, howdy from West Virginia. Oh, I am really struggling here. All right, well, let's end that struggle with a joke of the day because you know it brightens our day. So, if towels could tell jokes, I really think they probably have a dry sense of humor. All right, well, let's just wet our whistle here with a little bit of more talk about fractions, and we're going to take a look at equivalent fractions. So we need to understand that equivalent fractions, the word equivalent means equals, so they're going to be equal, but equal in what way? They are going to be equal in value. In other words, equivalent fractions represent the same value. Oftentimes we'll say they take up the same space. They have the same amount to them. In other words, they have the same value. So let's take a look at these three examples of fractions and really investigate what I'm talking about, this idea of same value. And doing this will lead us into the rules for how we make equivalent fractions. So this first example that says that I have 3/6. Now remember, we've talked about that you can represent fractions with circular pie pieces. You can represent them with lengths or portions of lengths. You can represent them with portions of a whole, any way you want. I'm going to continue to go with the circular pie pieces just because typically it's a little bit easier to understand. Plus, I just really love my magnetic pie pieces. They're so much fun. So, I have 3/6 of a whole pie. Remember, that denominator says, well, if I took that whole pie and I cut it into sections, this type of section, this size of section right here, it would take 6 of them to make an entire whole pie. And you can see that as I put 6 of these pieces together, you can see, yep, sure enough, they do make one whole pie. So this says I don't have all 6 of them, I only have 3 of these 6. So what I'm going to do now is I'm going to say that is the equivalent of what type of fraction, because I want to simplify it into lowest terms. Well, as I look at this, I say, you know what? It seems like that takes up the same space as 1/2. And sure enough, it does take up the same space as 1/2. So in other words, 3/6 is going to be the same as, it's equal to, it is equivalent to 1/2. Now, how would I go from 3 to a 1 and from a 6 to a 2? Well, you'll notice that I can go from a 6 to a 2 by subtracting 4, but if I take a 3 minus a 4, it doesn't give me a 1. I could also take a 6 and turn it into a 2 by perhaps dividing it by 3. 6 divided by 3 gives me 2, and if I take that 3 and divide it by this very same number, 3, it does give me 1. So perhaps that's how we get equivalent fractions. Well, let's take a look at another example here. Let's slide this 3/6 and my 1/2 over, and I'm going to keep those up there just so we can remember they take up the same space. Now let's take a look at this idea of 8/12. Well, I've got 8/12 sitting here, and remember, the denominator says if I was to take my whole pie and I was to slice it up into this amount, this value, this section, it would take 12 of these to make an entire whole pie. But I don't have 12 of them, I only have 8 of them. So here are my 8/12. Now, as I look at that 8/12, it looks like it has the same space, the same value of what other type of fraction? Well, just so happens that it takes up the same space as 2/3. And you can see, sure enough, it does take up that same space as 2/3. So in other words, 8/12 is equivalent to, equal to, has the same value, takes up the same space, the same amount as 2/3. Let's go with the idea that we had up here. How did we get from 3/6 to 1/2? We divided the numerator and the denominator by the very same number. So if that's the case, is there a number here that I could divide my numerator and my denominator by in order to get to a 2/3? What would I divide an 8 by to get a 2? Well, I would divide that 8 by 4. Can I divide that 12 by the very same 4 and get a 3? Why, yes, I can. So that does appear to be the way that we simplify our fractions into lowest terms. The idea of lowest terms means I want numbers, digits that are smaller than 3 and 6, smaller than 8 and 12. So let's go with that idea here with my 42 over 24, and I don't have pie pieces that represent 24. So we're just going to go with our rule. The rule said let's divide numerator and denominator by the very same number. Well, what would I divide 42 and 24 by? My first thought is let's divide them both by 2. So I'm going to go ahead and give that a shot, and I'm going to divide my numerator by 2 to get a 21. I'm going to divide my denominator by 2 to get a 12. But what I'm going to do is I'm going to say, am I done there? Because it says lowest terms. I want to keep dividing until there's nothing more that I can divide by. So is there a number that will go into both 21 and 12? Oh yes, 3 will go into both 21 and 12. So I'm going to divide my numerator by 3 to get a 7. Oops, let me get these out of the way so we can have some space here. And I'm going to divide my denominator as well by that very same 3. And when I divide 12 by 3, I get 4. So and I'm going to look at this and I'm going to say, is there a number that I can divide into 7 and 4? No, neither one of the only number that I can divide into each one of those is a 1. And 1 is not useful because when I divide 7 by 1, I get 7. Divide 4 by 1, I get 4. So it's not going to help me to, quote, shrink the fraction. Notice here it's not shrinking the fraction. None of these fractions, the 3, 6, did not shrink to 1/2. It doesn't shrink. It has the same value. It has the same size. We are shrinking the digits. We are reducing the digits, but we're not reducing the fraction. Frequently, and over the years, we've always said, reduce the fractions. But we want to get away from this idea of reducing because that word reducing makes us think that the fraction itself, the value is going to shrink. And you can see here, it's not shrinking. You can see right here as well, not shrinking in size. We are simply simplifying into lowest terms in terms of those digits. Now, I do want to point out, what if up here on that 8/12, what if you didn't think of the 4? What if, like down here, I only thought of the 2? Well, if that's the case, when I take that 8/12 and I divide numerator and denominator by 2, divide the 8 by 2, I get a 4. Divide the 12 by that very same 2, and I get a 6. But remember down here, I said, I'm going to keep looking this. I'm going to keep saying, is there more that I can divide? In other words, is there a number that will go into 4 and 6? Why, yes, there is. I can divide my 4 and my 6 by 2 again. 4 divided by 2 is 2. 6 divided by 2 is 3. That gets me right back there to that 2/3. So once again, the idea of being able to simplify into lowest terms, let's take a look at that rule. The rule says what I'm going to do is I'm going to multiply or divide. We haven't talked about multiplication. But I'm going to divide both the numerator, which is the top number, and the denominator, which is the bottom number. Notice I've put this in all caps and underlined it. Put this on all caps and underlined it. Because I want to do both the numerator and the denominator by the very same number. Same number. Now, when we are simplifying into lowest terms, we're going to do that division. But what if we're not simplifying into lowest terms? We just want equivalent fractions. What if we actually want a fraction that feels bigger, has the same value, it's not really bigger, but the digits are bigger? We're going to reverse the idea of division. What's the opposite of division? Multiplication. So we will multiply both the numerator and the denominator, the top and the bottom, by that same number. Again, because we just want different digits, but we want same value. Think of it this way. Whenever you divide or multiply numerator and denominator by the same number, let's take a look at this 3 over 3. Well, if I have 3 over 3, what is 3 over 3? 3 divided by 3. 3 divided by 3 is just a 1. How about 4 over 4? Well, 4 divided by 4, again, is just a 1. What about 2 over 2? Well, 2 over 2, once again, 2 divided by 2 is just a 1. So if I am dividing by 1, do I change value? When you take a 7 and divide it by 1, what do you get? 7. When you take a 5 and divide it by 1, what do you get? 5. So when you divide by 1, you don't change value at all. What about multiplying by 1? What if I take 7 and multiply by 1? What do you get? 7. What if I take 5 and multiply by 1? What do you get? 7. So dividing or multiplying by a 1 never changes value. That is why it's so critical, like you see here, numerator and denominator, top and bottom. That's why I put it in all caps and underlined it. Very critical that you multiply or divide both numerator and denominator by the same number. Because when you multiply numerator and denominator by the same number, you are multiplying or dividing by 1. And what we just demonstrated was that multiplying or dividing by 1 never changes value. So you are not changing the value of your fraction. You're only changing what it looks like. That 3/6, well, it doesn't look like 3/6 anymore. It now looks like 1/2. Here was my 3/6. Here is my 1/2. This 1/2 looks different than this 3/6, but you can see they have the same value. And the same thing down here with my 8/12, which I changed into 2/3. So 8/12 here and 2/3 here definitely has this different look to it, but you can see it has the same value. So that's why, again, so critically important that you multiply or divide numerator and both numerator and denominator by the same number so that you do not change value, not value, just looks. Now, some people will say, okay, can I add and subtract? As long as it's the same number on the numerator denominator, can I add or subtract by that same number? Well, let's take a look at this idea. Let's take that 8/12. Now remember, we already did 8/12. We already discovered that 8/12 was the equivalent of 2/3. I'm going to take these and I'm going to put them on the other side here so I can utilize them one more time. Whoops. But remember, we've already discovered that 8/12, oh, I'm struggling here, I'm very sorry. 8/12 is the equivalent of 2/3. All right, here's my 8/12. Let's put them up here. 6, 7, and there's the 8. And like I said, we've already discovered that 8/12 is the same thing as 2/3. However, let's go with this idea of, well, can I add or subtract the same thing in the numerator and the denominator? Whoops. So what if instead of dividing by 4 in the numerator and denominator, what if I said I'm going to subtract 4? And as long as it's the same number on the numerator and denominator, am I not going to get an equivalent fraction? Well, let's check it out. If I take 8 and subtract 4, I get 4. If I take 12 and subtract 4, I get 8. So that's saying that these 8/12 are going to have the same value, take up the same space as 4/8. Well, let me get my 8 pieces and demonstrate to you why no, this cannot happen. Here's an 8th. Remember, they need to take up the same space for them to be equivalent. There's 3 of the 8ths. I don't even have to get the 4th 8th. You can see, no, they do not take up the same space at all. And for them to be equivalent fractions, they have to take up the same space. This 4/8 would be the equivalent of 1/2, and you can see very clearly, where's my half piece? No, my 8/12 does not take up the same space as 1/2. So no, you cannot add or subtract the same number on the numerators and denominators. You can only multiply or divide by the same number on the numerator and denominator. If I was subtracting 1, because remember 4 over 4 would be the equivalent of 1. So if I take a number and subtract 1, do I have the same value? Remember we said if we multiply by 1, doesn't change value. If we divide by 1, doesn't change value. But let's say I took a 7 and I subtracted 1. Will it change value? Absolutely. 7 minus 1 is 6. If I took a number and I added 1 to it, let's take that 7. Let's instead add 4 over 4. Let's add 1. So if I take 7 and add 1, do I change value? Absolutely, it becomes 8. So in order to not change value, it has to be multiply or divide by both the numerator and denominator, by the very same number. This is key right here. Here is the process for creating equivalent fractions. So I hope that helped. Have a great day.